we have algebra of events. Actually, what is there in algebra of events, as you have done in set theory, universal set is there. Any set or every set is a subset of the universal set. In case of algebra of events, sample space is like universal set, and any event is the subset of the sample space. As in Venn diagram, we write geometrically the universal set by enclosing its elements inside a rectangle. Similarly, we have here in algebra of events the sample space geometrically is defined as by enclosing its elements inside a rectangle, and any subset of the sample space is designated by drawing a circle or by taking its elements inside the circle. And as we define complement of set with respect to universal set, similarly here we have complement of a complementary event or complement of an event. Suppose A dash. This A dash is equal to what is the set of all x, such that x belongs to sample space but x does not belong to A. So that part is complementary event. And as in set theory we do have A complement union A forms the universal set. It is also here A complement union A gives you the complete sample space. Now, as we have seen in algebra of sets, there are commutative law, associative law, distributive law, de Morgan's law. In case of events and sample space, these all properties also hold. And there are now some important terms of probability. One probability theorem is probability of A union B, where A union B is the same as for two sets we do have A union B, and the probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. But if A and B are disjoint, then A intersection B is null event and the probability of empty or null event is always 0. So therefore the probability of A union B in case if A and B are disjoint events, probability of A union B is equal to probability of A plus probability of B. Now probability of A intersection B. A intersection B is the simultaneous occurrence of both the events A and B, and the probability of A intersection B is equal to the probability of first event into the conditional probability of the second event. And like this probability B only A, it means the probability of occurrence of the event B given that A has already occurred. Or we can define the conditional probability of happening of B given that A has already occurred is equal to probability A intersection B divided by probability of A. But if events are independent, if two events are independent, how do we define the independent events? If the probability of occurrence of one event is not affected by the occurrence or non-occurrence of the other, then the two events are said to be independent. And in that case, probability of A intersection B or probability of the simultaneous occurrence of the two events A and B is equal to product of their separate probabilities, that is probability of A into probability of B. Now we have random variable. A random variable X is a function whose domain is a sample space and whose range is Rx, non-empty set of real numbers. Or we can define a random variable as random variable is a rule or function by which we can assign a real number with each of the sample points. Now, probability distribution of a random variable. If we have discrete random variable which can have countable number of values, then probability of x is equal to px. Here px is called the probability function, and sum of all probabilities is always 1. For example, tossing a coin thrice, if I define this random variable that x denotes the number of heads, then by this rule I can assign to the first sample point 0 number, no head, then there are one head, and then 2 head, and all the 3 heads. Therefore, to the random variable counting the number of heads, we can assign the value 0 or 1 or 2 or 3. Now what are the probabilities? When x is equal to probability x is equal to 0, what is the probability? Favorable case only 1, t. And if head is 1, then there are 3 favorable cases, th. So the required probability when x is equal to 1 is 3 by 8, when x is equal to 2, again there are 3 favorable cases, 3 by 8, and then h. This is h. This number is 3. Again only 1 point favorable, so the required probability is 1 by 8. And then you can add all these probabilities, you will get 1. So this is the case of discrete random variable. Now continuous random variable. If x be a continuous random variable and x is less than infinity, greater than minus infinity, then a continuous function fx, where fx is greater than or equal to 0, and the integral value minus infinity to plus infinity fx dx is equal to 1 is called a probability density function. So therefore every continuous function is not a probability density function. For a function to be probability density function, first condition fx greater than or equal to 0 and integration minus infinity to plus infinity fx dx is equal to 1 must be satisfied. Then the fx is a probability density function. And now the question is how to attach a probability in case of continuous random variable. If you take a particular point, then the probability is 0. If you say in continuous case, what is the probability x is equal to 1, what is the probability x is equal to 2, then it is 0. But here we define or we attach the probability to an interval of the range. For example, probability x less than x plus dx by 2, x minus dx by 2, where dx is a very small and is equal to fx dx. And the probability x less than equal to b greater than or equal to a is equal to integration fx dx. So as you can see from this diagram, what is the probability when x belongs to an interval AB? So that is the area under the curve y is equal to fx and x-axis and between the ordinates a to b, and if fx is a probability density function, the total area is unity. Now, mean and variance of a discrete and continuous random variable. The mean of a continuous random variable is given by this Ex is equal to summation x px, where px is the probability function, whereas in case of continuous random variable it is x bar is equal to minus infinity to plus infinity x fx dx. You will be thinking that is in every case the limit for integration is minus infinity to plus infinity. No, this is not there. This is the actually entire range. If the random variable has been defined between 10 to 20, so then in that case integration 10 to 20 fx dx will be 1. So now variance, as you know, variance you have done in frequency distribution also. So in case of discrete random variable, it is summation of x minus ex. Ex is mean or expected value. This x minus ex whole square. Whole square px. And if it is continuous variate, then it is minus infinity to plus infinity x minus x bar means ex, expected value or the mean, fx dx. Or sometimes we do use the second formula for calculating the variance, infinity minus infinity to plus infinity x square fx dx minus mathematical expectation whole square. So this is about another function. In case of discrete, it is probability function. In case of continuous, probability density function. But there is another function which is known as cumulative distribution function. It is there in case of discrete random variable. It is also there in case of the continuous random variable. So if and it is always designated by using capital letter F, and this fx is equal to probability sum of all probabilities x less than or equal to small x. And in case of continuous random variable, it is minus infinity to x fx dx, and it is always there. If you do have the probability density function for a continuous cumulative distribution function, if you do have cumulative distribution function for continuous random variable as fx, then we differentiate it and get the probability density function. Now, this variance we have already defined. Suppose variance is E of expected value of x minus mu whole square, where mu is expected value of x, or we define it by second formula, expected value of x square minus ex whole square. Now some important probability distributions. You have done binomial distribution, which is also a discrete distribution, but a special case of binomial distribution is the discrete Poisson distribution. So we can say only Poisson distribution. How to define this Poisson distribution? A discrete random variable having probability function Px is equal to e to the power minus lambda to the power x over x factorial, where x is equal to 0, 1, 2, 3, lambda greater than 0. lambda is greater than 0. Here, in case of this Poisson distribution, here lambda is a parameter and which happens to be its mean or the mathematical expectation. The variance of Poisson variate, the variance of Poisson variate is also lambda, that parameter. Now one numerical example. The number of customers arriving at a facility for service between 10 a.m. and 11 a.m. is a Poisson random variable, say x1, with mean 2, as there is only one parameter involved in Poisson distribution. So here lambda is equal to 2 or mean is equal to 2. Similarly, number of customers arriving between 11 a.m. and 12 noon, say x2 has Poisson distribution with mean 6. If x1 and x2 are independent, we are interested in knowing probability that more than 5 customers will arrive between 10 a.m. and 12 noon. Now, between 10 a.m. and 12 noon, one discrete random variable is there for 10 to 11, another Poisson variate is there for 11 to 12. So therefore here we are interested in the random variable x1 plus x2. But there is one important property of Poisson distribution, that sum of two Poisson variates is also a Poisson variate, and its mean is the sum of two means, sum of the separate means of the two random variables, as in this case x1 plus x2 has a Poisson distribution and its mean will be 2 plus 6 is equal to 8. And now what is the probability law for this discrete Poisson distribution? It is there, probability x is equal to x. Now here x means this sum of the two discrete Poisson variates, and this discrete Poisson variate, which is equal to x1 plus x2, has a parameter or the mean or the expected value as 8. So therefore now lambda is 8, e raised to the power p x is equal to x is e minus 8, e to the power minus 8, 8 to the power x over factorial or x factorial, where x is equal to 0, 1, 2. Now we have been asked here to find the probability x greater than 5. Now it is equal to 1 minus probability of x less than or equal to 5, and it is equal to 1 minus summation x is equal to 0 to 5 e minus 8, 8 raised to the power x factorial x, and you can calculate this value. This is here, and you can substitute in this. First x is equal to 0, then x is equal to 1, x is equal to 2, x is equal to 3, x is equal to 4, x is equal to 5. Now it is the sum of all probabilities, and it is coming here 0.1912, and 1 minus that is 0.8088. So this is the probability that more than 5 arrivals will be there in the interval 10 a.m. to 12 noon. So this is about this Poisson distribution. Now another is normal probability distribution, which is a continuous probability distribution. And you will be aware about this distribution. A continuous random variable x having probability density function 1 over sigma under root 2 pi e raised to the power minus half x minus mu by sigma whole square, where x less than infinity greater than minus infinity. So this is the probability density function, but here two parameters are involved, mu and sigma. This mu happens to be the mean of this distribution or the expected value, and the variance of this distribution is this sigma square. Now another form of this normal probability distribution is also there, which is known as standard probability distribution. And this standard normal probability distribution is obtained by making the transformation z is equal to x minus mu by rho, and then the probability density function for this distribution is 1 over under root 2 pi e raised to the power minus half z square, and the mean of this distribution is 0 and variance is 1. Now, properties of normal curve. One of the important property of normal curve is that mean, median and mode coincide here. And in case of this standard probability distribution, for this mean is 0, mean, median, mode also coincide, and this mean is 0, and range also minus infinity to plus infinity. But another important property of this normal curve or normal distribution is that more than 99% of the values of normal random variable lies between mu minus 3 times standard deviation and mu plus 3 times standard deviation. 0.9973. Its probability is 0.9973. It means more than 99.73 values of the normal random variable lies between mu minus 3 times standard deviation and mu plus 3 times standard deviation. But in case of standard normal distribution, this mean happens to be 0 and variance is 1. So therefore 99.73% or of the values of the standard normal variate lies between minus 3 to plus 3. So therefore a statistical table has been made to find the probability for standard normal curve between minus 3 to plus 3. We don't have to go to from minus infinity to plus infinity, as more than 99% of the values of the variate lying between minus 3 to plus 3. So now this is the end of this lecture. I will take in my another lecture some of important and other distributions like exponential distribution. And I taught you here that Poisson distribution and exponential distributions are very important for the study of twin theory. If arrival is random, it always follows a Poisson distribution. The arrivals reaching at a service station always has a Poisson distribution. And if arrival has a Poisson distribution, then the time between two successive arrivals always has exponential distribution. So therefore in my second lecture, I will take this exponential distribution and then I will define Poisson process and will start twin theory. Okay, thank you very much.